Hello class, today we will be talking about section 5.4, applications of percent. The first application that we're going to talk about is finding a sales tax. To find the sales tax of an item, you simply multiply the price of the item by the sales tax rate as a decimal. Looking at the example below, we want to find the sales tax of an item that costs $4.50 when the tax rate is 4%. Our first step is to turn the 4% into a decimal. To turn a percent into a decimal, we simply have to divide our percent by 100 or move our decimal point back 2 places to the left. 4% as a decimal is 4 hundredths. Now I'm going to take the 4 hundredths and multiply that by my $4.50. When I do this, I get 5 times 4 is 20, carry my 2, 4 times 4 is 16, plus 2 is 18. I notice I have 3 numbers after my decimal total, so therefore in my product I need 3 numbers after my decimal as well. Therefore, I see that my sales tax is 18 cents. Please take a moment to pause this video, record the process for finding sales tax, and the example in your notes. Next thing we want to talk about is finding the total cost of an item with sales tax. The first method is to find the sales tax and add it to the price of the item. So if I wanted to find the total price of the item with the sales tax included, for example, to the left, I would add 18 cents to $4.50, and I would find that the total cost of my item is $4.68. The second method is to multiply the cost of the item by 1 plus the sales tax rate as a decimal. Remember, we always want to turn our percents into decimals when we are working with them. The reason why it's 1 plus the sales tax rate is 100% as a decimal is 1. So we're paying 100% of the item plus the percent of the sales tax. So with the example off to the side, if I was paying 4% tax rate for $4.50, I would multiply 1 and 4 hundredths by $4.50. 5 times 4 is 20, carry the 2. 5 times 0 is 0, plus 2 is 2. 5 times 1 is 5. Put the 0 as a placeholder. 4 times 4 is 16, carry the 1. 4 times 0 is 0, plus 1 is 1. And 4 times 1 is 4. If I add these together, I end up with $4.68. You'll notice that either way, you'll get the same answer, so use whatever method makes most sense to you. Please take a moment to pause this video, record both methods in your notes, as well as the example of finding the total cost using the second method. The next application of percents that we're going to talk about is finding a tip. To calculate the tip, you multiply the total bill by the percent you want to leave for a tip. Remember, you always want to turn your percent into a decimal. Looking at the example below, if the bill is $65.23 and you want to leave a tip of 20%, you would first have to turn the 20% into a decimal. 20% as a decimal is 2/10. Then you're going to take your $65.23 and multiply it by 2/10. 2 times 3 is 6, 2 times 2 is 4, 2 times 5 is 10, carry the 1, 2 times 6 is 12, plus 1 is 13. We notice there's 3 numbers total after the decimal, so there should be 3 numbers total in our product, and we get that our tip is approximately $13. Please take a moment to pause this video, record how to calculate a tip, as well as the example in your notes. Now I'd like to talk about finding a commission. The first thing we need to do is know exactly what a commission is. A commission is a percent of a sales associate's total sales that is paid to them in addition to their salary. Please take a moment to pause this video and write down the definition of a commission. To find a commission, multiply the total sales by the commission rate as a decimal. Let's try an example together. 3.5% as a decimal is 35 hundredths. Now I'm going to take the 35 hundredths and multiply it by 300. I can simply do this by 35 times 3 is 105, and then I add 2 zeros onto the end. There are 3 numbers total after the decimal, so I need 3 numbers total in my product as well, and I get that the commission is $10.50. Please take a moment to pause this video and record the example in your notes. The last application of percent that we will be exploring is finding percent error. The equation for finding percent error is the absolute value of the actual value minus the measured value divided by the actual value times 100. Please take a moment to pause this video and record this equation in your notes. Now, some of you may be wondering exactly what absolute value is. Absolute value is the distance from 0, and it's represented by these bars here. Since absolute value is the distance from 0, and distance can never be negative, if I found the absolute value of -2, that would be +2. If I find the value of 2, that is also +2. Since -2 and 2 are the same distance away from 0 on the number line, they have the same absolute value. Let's try an example of finding percent error. At a factory, each nail created is 6 inches long. If the length is not within 0.05% of the specified length, it will be rejected. Is the nail that is 5 7/8 inches rejected? Let's see, the first thing we need to do is set up our equation. So we take the absolute value of our actual value, 6, subtract the measured value, 5 7/8, divide it by our actual value, 6, and then multiply by 100. When I take the absolute value of 6 minus 5 7/8, I get the absolute value of 22 hundredths, which is simply just 22 hundredths. So I get 22 hundredths divided by 6 times 100. 22 hundredths divided by 6 is approximately 4 hundredths. 4 hundredths multiplied by 100 is 4. Therefore, 4% is our percent error. Since 4% is larger than 5 hundredths of a percent, the nail that is 5 7/8 inches is rejected. Please take a moment to pause this video and record the example in your notes. Now I would again like you to take a moment to pause the video and try these 3 problems on your own. After you've attempted them, please resume the video and correct your work. After going through and solving the problems, I went through and I turned all of my percents into decimals first. Then I did my multiplication on the first one. So 299 times 25 thousandths, and I got 7,075. I needed 5 numbers after my decimal, so I added a 0 and put my decimal, and got that my sales tax was approximately 7 cents. Therefore, the total cost of the item is $3.06. In the second one, when I calculated my tip, I multiplied my bill, $13.26, by 15 hundredths, and got that my tip is approximately $2. For the percent error, I subtracted my measured length from my actual length, and got 5/100ths. I took the absolute value of 5/100ths, which is still 5/100ths, divided that by 4 5/10, and multiplied by 100, and got that my percent error is approximately 1%. Before you finish taking your notes, I would like you to list at least 3 ways that you use percents in your everyday life, and try to think of at least one more application of percents in real life. Please come to class prepared to share your responses.